Hello guys, welcome back to my channel. My name is Gede Pasek Arya Sunanjaya. My student identification number is 230553107. Then my lecturer is Prof. Tjokorda Gde Tirta Nindhia, STMT M Eng. From subject Metallurgy, TM 2301, and today I will show you my presentation about discovering metals, a historical overview. So guys, this is my profile. My base reference from book Metalurgy for Non-Metallurgists, edited by Arthur C. Reardon. So this is my list of my contents. First are the first native metals, second the Bronze Age, third making metals extractive practice, the fourth iron, fifth discovery of modern metals, and sixth refining of metals. Native metals. Most metals naturally occur as minerals or compounds. The metal atom has reacted with other metals or with non-metallic atoms. One of the primary tasks of the metallurgist is to extract the metals from the compound. The few metals that are found in an unreacted state are termed native metals. Through the use of native metals, the science of metallurgy was born. The Bronze Age. The Bronze Age began when it was discovered that mixtures of two metals or alloy were stronger than either of the metals taken individually. This discovery was probably made about the same time that extractive metallurgy was discovered. The discovery that tin alloy addition the strengthened copper was the crux of the Bronze Age. A chemical analysis of the typical bronze alloy from the ancient Middle East shows that the alloy contained approximately 87% copper, 10 to 11 tin, and small amount, less than 1% of iron, nickel, lead, arsenic, and antimony. It is rather startling to realize the approximately 4,000 to 5,000 years passed between the advent of the Bronze Age and the development of turning silver. A more modern application of the strengthening effect of alloy additions, Sterling discovered that the strength of silver could be improved greatly by the addition of small amounts of copper. This small addition, approximately 7.5%, did not affect the appearance but significantly improved the surface ability of silver vessels, jewelry, and utensils. Even more startling may be the persistence of ancient metallurgical practices into relative modern times. An 11th century description of bronze states that it is an alloy consisting of 1 pound of copper and 2 ounces of tin, or 88% copper and 12% tin. This alloy is remarkably similar to the 87 copper found in ancient bronze. Other publications suggest that a soft bronze of copper are mixed with 1 part of tin, that a hardened gunmetal such as was used for bronze ordnance is formed when the proportion of tin is approximately double. This hardened gunmetal contains 88% Cu, or copper. Making metals extractive practice. Most metallic elements occur naturally as metal or ores, which are compounds that result from a reaction between metallics and non-metallics atoms. Most copper, zinc, and lead ore are sulfides, while iron and aluminum is generally found in oxide ore. Extraction of metals from their respective ores requires work or energy to separate the metals from the sulfur or oxygen. This energy can be supplied in the form of heat, and the first extraction were probably accidental. The extraction of copper from the copper sulfide ores and from the other ore deposits required that the early metallurgists reverse a reaction that had occurred between copper and another element found in the earth crust. Melting of copper also resulted in the discovery of alloying and the Bronze Age. The main method of extracting metals are pyrometallurgy, or using heat, hydrometallurgy using water, and electrometallurgy using electric current. Pyrometallurgy is the extraction of metal from ores by chemical reaction at high temperature in fuel-fired furnace. Pyrometallurgy may involve roasting and or smelting for the extraction or refinement of metals. Smelting refers to melting process that separate metal infused from non-metallic materials. Hydrometallurgy is the leaching or removal of metal from an ore body by passing strongly acidic or alkaline solution of the ore. Electrometallurgy involves the extraction of metal from the ore by the application of large amount of electrical energy. Iron. The early name of iron means stone from heaven in several languages. This name probably resulted because the first iron used by ancient men was literally from heaven. Meteorites weight from few ounces to tens of tons have been falling to Earth since beginning. The meteorites frequently contain large quantities of metallic iron, and the first iron used by ancient men was from these stones from heaven. Iron is a chemical element. The atomic number is 26 Nfe, or Latin ferrum. For the symbol is a metal that belongs to the first transition series and group 8 of the periodic table. It is by mass the most common element on Earth, forming much of Earth's outer and inner core. These are several types of iron based on their carbon content. First, pure iron. Pure iron has a very low carbon content, usually less than 0.03%. It is the purest and softest iron. Second, worth iron. Worth iron has a carbon content of around 0.02 to 0.08%. This is an iron that has a low carbon content but is quite corrosion resistant. Cast iron. Cast iron has a high carbon content, usually between 2 to 4%. This is a very hard and brittle iron. Steel. Steel is iron that contains carbon in range of 0.2 to 2%. It is the most commonly used iron in construction and manufacturing. Discovery of modern metals. The use of the Latin suffix in naming of metals such as beryllium is typically of the suffix on all metals discovered or isolated after 1800. Many of these metals have tremendous commercial importance, primarily because of their use as alloying elements. Beryllium, or Be. is added to copper to improve its strength. The mechanism or process by which beryllium increases the strength of copper is very different than the strengthening that results by tin or zinc addition to copper. Zinc's additions to copper produce braces. The copper beryllium alloy contains only a small amount of beryllium, approximately 2%, but can be processed or heat treated to be much stronger than any low tin brass or copper zinc alloy. Cadmium was discovered in 1870 and is primarily found in zinc ore. Cadmium coating or plating were used to protect nuts, bolts, and other components made of high-strength steel or other relative corrosion-prone metals. The cadmium plating acts much like some paints and limits the access of the environment to the protected component. Many of the components is commercial aircraft or cad plated. Chromium was discovered in 1798 and used mainly as an alloy addition in steel production. Chromium improved the resistance of steel to oxidation and corrosion and is an essential ingredient in stainless steel. Corrosion will severely limit the utility of the steels if chromium was not added. Stainless steel contains up to 30% Cr, and although the primary function of chromium addition is to improve the corrosion or chemical behavior, chromium in small quantities improves the strength of alloy steels. Molybdenum was discovered in 1781 and is primarily used as an alloy addition to steel. However, molybdenum melts at 2620 degrees Celsius or 4750 Fahrenheit compared to 1535 Celsius or 2795 Fahrenheit for iron. Tungsten was first refined from ore in 1783 and was originally called wolframium. Tungsten was first used as the filament for the incandescent light bulb, and this use accounts for 15 to 20% of all tungsten use. Vanadium is among the hardest of all relative pure metal. It was discovered in 1830 and is actually more abundant than copper, nickel, or zinc, but it's very difficult to purify. Alloy addition steel. Vanadium is primarily used as an alloy addition to steel for the manufacture of woodworking and metalworking tools. Magnesium is the lightest of the widely used structural metals. Refining of metals. Refining of metals refers to process that purify extracted metals. Refining of metals, like the extraction of metals from ore, includes many ancient practices and more modern advance. For example, gold always occurs in metallic states, and it can be extracted from metals by relative simple means. So guys, that's all of my presentations. As always, thank you for watching my video. See you on the next video. Bye bye. Gede out.